All right, so in today's lesson, we'll be talking about this, the change of base formula. But first, where does this formula come from? So it starts off with saying, let's let y equal log base b of x. So using properties of logs, we know that this means b to the y is equal to x. So after that, what we'll do is we take the log of both sides. So that ends up being the log. I'm going to use a different base. So say a of b to the y equals the log base a to the x. So we can pull this exponent out here. So y times log base a of b equals log base a of x. And again, we solve for y by saying that y is going to be equal to log a of x over log a of b. So if you look at this formula up here, you'll see that the log base b of x, is equal to the log base a, some other base, of x over the log base a of b. So a lot of people might wonder, well, why do we need to do this? Well, the reason we need to do it, and it's maybe computationally passé now, but before the TI-83 or 4, there were two buttons on our calculator. There was a natural log button up here, and there was a log button down here. So we had to put everything into the common log or into a natural log. So that's where this comes from. But it's still taught in our pre-calculus classes. So let me show you a couple of quick examples of how this plays out. All right, so here's a first example, log 8 of 5. So that means log base 8 of 5. So 8 to what power is going to equal 5? That's what it is we're looking for. So in order to do this, prior to your TI-84, you would have had to say, well, this would be equivalent to, say, the common log of 5 divided by the common log of 8. Note again that we don't have to put the 10 down here. Or if there's no 10 there, it's implied that this is a common log. So when I type this into a calculator, because I do have a log button on a calculator, so I could type this into my graphing calculator or any calculator, and I'd come up with about 773,976. So what that tells us is that 8 was my base number to start with. 8 to the 0.773,976 is about equal to 5. And I think it'd be like, that was rounded down, so you'd probably come up with like 4.99999 and so on. So, but anyway, the reason for this was back in the olden days, there was only two buttons on a calculator, natural log and common log. Let me show you a second example. Okay, so now we're going to try to evaluate the log base 9 of 20. So using this change of base formula, we would say, well, that's going to be, let's use a different one this time. Instead of common log, we use the natural log. So a lot of times I write the natural log out sort of in cursive like this. So the natural log of 20 divided by the natural log of 9. So when I type that into my calculator, what would I get? Let me see. 1.363417. So that tells us the exponent that you would raise 9 to get 20. So 1.363417 is about 20. So if you type this into any calculator, you're going to get approximately 20. And that I rounded up So that's going to be a little bit over 20 if you type that into a graphing calculator to figure that out. But in case you're wondering, new graphing calculators have a change of base formula. The reason you'll see, especially, this is just a side note to some students, if you see log base 7 of any number, a lot of times you'll see this on take-home stuff, like take-home quiz, take-home test, assignments, because PhotoMath does not do such a good job on log base 7. So just be aware, if your teacher is putting log base 7 on things, it's because they know that log base 7 doesn't come out so good with using devices like PhotoMath or apps like PhotoMath. All right, so when else might we come into this prior to TI-84? Let me show you a third example. Okay, welcome back. This is a third example. Suppose you had to graph a function. It said f of x equals log base 7, we'll keep with that 7, of x prior to the common age, I guess I'll call that. We know that it's a log, so we know about what this is going to look like. But what we'd first have to do is to graph this into the graphing calculator before they had a base change formula is you'd say, do we want to use log or natural log? I'm partial to the natural log just because I think the button was more prominent on my calculator that I used back in high school. So log base 7. All right, do I need these parentheses here? No, I don't. Yay! So these are not needed, but they show up in your graphing calculator. So if you type this in to your like y sub 1 on a graphing calculator, it's going to give you the same as what's up here, log base 7 of x. All right, so like I said, new calculators will do this. These are a little bit trickier to solve when we have them, but we'll look at a couple of those later on. So in any event, this ends up graphing how? We know that it's a log, so it's going to cross 1 here, and it's going to look like this. So the one thing calculators do is they kind of make it stop and make you think that it stops right here. But it doesn't. It keeps going down asymptotically to the y-axis, and this just keeps going out this way to infinity in the x direction. Okay, so if you type this or this, if you have a calculator that does this, into your graphing calculator, this is what it will look like. So that was another reason why back in the old days we had the basic change formula, which you see up here. Admittedly, that is computationally passé these days, but you still might need to do it in case you have, in the old days, they only had tables really for logs, common logs and natural logs. So if you have a common calculator and you're going to take a test that allows you to use it, then okay, fine. Don't worry about this stuff, but you should still worry about it because it might show up on a college entrance exam. It may show up on any other types of exams. So the only thing you will have tables to are common logs and natural logs. All right. Hope you got some benefit out of that. If so, please go ahead and share it with a classmate and hit the like button down below. See you on the next one.